Hey there, IT 145 students. So in this recording, we're going to go through the first portion of Chapter 1 in zyBooks, where this is going to deal with basically programming and programming in general. So first thing to understand when you are creating programs is that you are dealing with getting input, doing something with that input, so processing it in some way, and then displaying the output. That's the majority of what computer programming actually does. So we're going to get data from somewhere. We might read it from a file. We might have a user type it in using a keyboard. Somehow we get our input. And then again, we're going to perform some kind of computation. We're going to do something with that data. So, if we've got a really simple example here, we're just going to add X and Y together. Uh, Once we've performed our computations, we're then going to display the output somewhere. We might write it to a file. We could display it to the console or to the screen. We could save it in a database. So some action is going to be performed. So keep in mind, this is what we're always doing. We're getting inputs, we're doing something with it, and then we're going to display the output. So oftentimes, while we are performing this input, processing, and output, we're going to be using variables. So you can use variables to represent data while you are working with it. Now, we'll get into some more details about variables later on in this, but just keep in mind, for instance, they've got a real simple example. They're going to say, go get an input, save it to a variable called X. Get another input, save it to a different variable Y. Keep in mind, if I use the same variable, whatever the last action is what's going to be contained in it. So we have two different variables here. And then we have a third variable that's going to hold the sum. So z is going to hold the sum of x and y. And then we're just going to put z to output. So this would display the output of whatever z contains to the screen. So this is a very common pattern we're going to use. Again, I like the idea that they have separate variables for each of the inputs. I really like that they use a different variable for the output because that's one of the code guidelines that I have for you. Always save results to a variable and then display the variable values to the output. Okay, let's go take a look at section 2. So in section 2, let's take a look at some actual Java code. So big idea that you need to understand in the Java programming language is that every Java application has a main method. Doesn't matter what program it is, they all have a main method. So I can come down here and I see in this class they have a main method, and the main method is always public, static, void. Public means it's always accessible. Static means there's only one instance of this method available. Void means this method does not return a value. And again, it has to be named main, has to be lowercase, cannot be a capitalized letter. And then inside the parentheses, it takes an array of string values. So every Java application is going to have a public static void main method. Next thing you'll see is that we have some curly braces right here and here. So in Java, curly braces are used to represent a code block. So code blocks could define methods like we have right here. Or if we have a decision structure or a loop structure, things that we'll learn about later on in our course, they're always enclosed in a curly brace. I know some of you are coming from a Python background. The curly braces, this is the same idea as in Python where you had a colon that defined a method, and then you had indentation that was determining which statements were a part of that code block. While we indent our code here in Java, the indentation does not define the method. It's defined by the curly braces here and here. So these curly braces define the method. These curly braces, this one that opens, this one that closes, those define the class that we are writing our code in. So newer programmers do things like this. They highlight some stuff, they click the delete button, and if I were to delete this curly brace right here, we're going to get a syntax error because we have to have matching curly braces. So always keep the code syntax free. Use the ID. If you see any red squigglies, you need to stop. You need to go back to the previous state, get the code in a workable state. Now, next thing it does say here is that each statement typically appears on a line and ends with a semicolon. So anything that is telling the computer to do something always has to end in a semicolon here in Java. So for instance, public static void main string array args. This is not telling the computer to do something. So there's no semicolon here. However, int wage, this is saying I want a variable called wage. So computer, give me a variable called wage. So it ends in a semicolon. This line right here, this is saying I want you to assign the value of 20 to that variable. So again, it's saying computer, put 20 in for this value. Again, we're telling it to do something. System.out.print or println. This is saying, all right, I want to display some outputs to the console. So again, has to be terminated by a semicolon. Okay, so continuing on, getting input for a simple Java application, we use what's called the scanner object. So we're going to have an import statement. So just like in Python, you used import statements in Python. So anything that's not part of just the simple standard library, you have to import. So down here, we've got our import java util.scanner. Imports always go before the class. And so right here, you can see they're going to declare a scanner. They've shortened the variable name to just be SCNR. Again, we know that it's a scanner, so they've got a variable called scanner. And then we go new scanner system.in. So what this lets us do is this is going to let us type in input at the console and then read it in. So right here on the next line, we can go scanner, and it has a next int option. And so we're going to save the integer value saved into the wage variable. Let's go ahead and just kind of run this. Let's see what happens. Let's go ahead and open up Eclipse. So again, I want you to have that saved locally on your machine. And let's go pick our IT 145 workspace. If that's the only one you have, it'll default to that. And let's just go ahead, and I'm just going to go ahead, and I've already got a Hello World project created. If you don't have one, you can go new Java project, and we'll just go module 1. And I want to use the default JDK. Again, if you followed my setup, this is all in there. And we've got this unchecked. Great. I'm going to go ahead and click Finish. I'm going to close out what was in here previously. Right click, Add New Class. And I'm just going to call it Source. I want that static void main method created for me. And great. We've got our Eclipse opened and ready for some code. I'm going to go ahead and get both of these visible so I can kind of copy and paste. And let's go ahead and just copy and paste this code that they have right here. Control C. And I don't want the class name. I just want the code inside the main method. Just this stuff right here. All right, so you can see without the import that the Eclipse is complaining. So Eclipse is smart enough. It says, oh, I know what scanner is. You need an import for that. So we can go ahead and just let Eclipse import that for us. So the way this is going to work, if I click the run button here, let me go ahead and right click on this file and go run as Java application. So down here at the console, it's waiting for us to type in an integer value. So we'll type in 100. So we type in 100 and I press enter, and it took the 100 times 40 times 52. If you don't believe it, we can run that calculation ourselves. 100 times 40 times 52. Great, we get the same thing right there. Now again, keep in mind, as we mentioned earlier, if you have syntax errors, so I have a miss and semicolon, this is not going to run. If I delete this curly brace, I'm going to have syntax errors. Make sure that you always keep the code syntax free. Oops. Another thing that I want to point out to you is that scanner object. If we hit the dot operator and type next, we can read in different types of data. So we were reading in an integer, but if we were going to read in a decimal type number, we might choose to use double or float. If we had a value that was going to be bigger than an integer, we could use the long operation. Or if we're going to read a really small integer value, we could use the short. If we just read in dot next, then we would read in a string. So keep in mind, there's different ways to read in the input. And with Java, you have to use the proper method. So if I try to read in dot next, it's going to complain because this returns a string. It cannot turn a string into an integer. If I do dot next long, it's going to complain because it cannot turn the long data type into an integer. So you always need to make sure you know what data type you're expecting. I want an integer value, so I need to use the int method. Okay, scrolling on down. So again, we see that the output they used was using the system.out.print method or system.out.println method. What the print method does is it prints on the same line and keeps writing text. So you can see here, if they just do dot print, we'd have keep calm, and then and is put on directly afterwards. Carry on is put on directly afterwards. To be honest, 9 times out of 10, you're never going to ever do this. Okay. You're going to want to print one line at a time. And so you use the print ln method. This will print the line of text and it's going to print a new line character and put the next line of data on its own line. So you're always going to be using the print ln. Oh, by the way, yes, I know this is different than in Python. In Python, you just use one keyword print. In Java, it's system.out.println. It's different syntax, okay? So don't ever get hung up that you think that, oh my gosh, I'm doing more things to just print out a line of text. It's just syntax. Oh, by the way, we can output multiple lines with one statement. So instead of having salary is and then having a separate print statement here, we could have just done this. Let's go ahead and just delete this up to here. I'm going to use println. And so if I want to display text and something else at the same time, we can use the plus operator. This is going to concatenate these two pieces of information together. And so if we run this, it's waiting for me to type in something, so I type it in, and so it's going to join these two pieces together. Now, it's going to perform this arithmetic prior to this concatenating operator. So if you wanted some kind of arithmetic in here that was doing addition, then you have to encapsulate it in parentheses. And oh, by the way, I don't want you doing this kind of work anyway. What I want you to do is perform the work where you save off the details, the calculation, to a variable. So we might do something like this, declare a variable called salary, and I'm going to cut this calculation, and I'm going to display the text, and I'm going to join the variable value to it. Oh, by the way, I don't need these parentheses here anymore. That was only needed if I was performing that action in a print statement. So now when I run this, I get the exact same result, and this is the style that I want you to adhere to here. Okay, next thing that they talk about here is comments and white space. So in Java, if you want to make a comment, keep in mind these are things that programmers leave behind to help better understand the code. We can do a single line comment that's 2 forward slashes, or you can use a multi-line comment where it starts with a /* and ends with */. So for instance, so I've got a comment here, get the user inputs, or if I want to have a block, I do /*, press enter, and this is a multi-line block. Anything in here is ignored. So if I do system.out.println, hi there, that's never going to be displayed. So watch when I run this, and I've got oops, I put a period on there. Let me rerun that. And so this runs. I don't ever get this print statement because it is commented out. Okay. They also mention, scrolling down here, that we can do a JavaDoc comment. So JavaDocs are on methods or on classes. So if I go /2 stars, press enter, this is a JavaDoc comment. This class is the main source file for the application. And I hover over this and I can see that documentation right there. If I JavaDoc this method, this is the main method. You can see that it put a param in args. That's this parameter value here. List of arguments to work with. And if I hover over main, I can see that it's telling me the text that I have, and I see the parameters down there as well. So any method or any class should be JavaDoc'd just like you see here. We do want you to use white space appropriately. So there should always be a blank line kind of separating blocks of information. So you can see they're declaring all their variables here. And so now we're going to print out some prompt and then read in a value. And again, we want to use some white space judiciously to kind of separate what we're doing here. So declaring our variables, getting the first input, getting some calculations performed, performing the output. We want to separate those with some white space. Also, we want to use proper indentation just to make the code readable. Again, if I do things like this and have, that over here and, this all the way over there and, doing weird things, it makes the code more difficult to read. It'll run just fine, okay? Remember, it's not Python, where it depends on indentation to define code blocks. It just makes the code more difficult to read. Again, we've already kind of introduced some syntax errors, so they kind of walk through here in section 1.4. Again, if I have an invalid, syntax, if I don't terminate this line with a semicolon, that's going to be a problem. If I try to use a variable that doesn't exist, so capital W wage, it says I don't know about this. So it's not going to run. If I run this, it's going to say error exists. Don't ever click the proceed button. This is going to run the last time that it compiled properly. So you watch. Oops, it won't even let me do it. So always click cancel and you have to go find your error. As they point out in the section here, sometimes you get some nice details. They're telling us there's an issue on line 19. Wage cannot be resolved to a variable. So keep the code syntax free. If I come over here, this errors list, if you have more than one error in here, then you've got something seriously wrong. So again, I'll do this, save. So I should have 2 errors in here and I can click it. I can see that I'm probably missing a semicolon. I've got a variable that doesn't know about. If I even get rid of braces, save. Now I've got 3 errors. So always, always, always keep the code syntax free. Scrolling down, aside from syntax errors, you might have logic errors. So logic errors aren't errors that the compiler catches. These are errors created by you. So for example, a programmer might want to be doing some multiplication, but perform an addition instead. So right here, this was supposed to be multiplication, right? You're doing a total, so that's the number times the number of jars. Oops, we did addition. This is a logic error. So these, to get caught, require you to go in and figure out why the code isn't performing what it's supposed to be doing. So we'll talk about that in a little bit on how you can trace that down. Next section in section 1.5, the only thing I want to point out to you is we've been writing programs since the 1940s. Uh, Early computer programs started out where they used a sequence of zeros and ones. Underneath the hood of a computer, you have computer memory, and everything is represented as either a 0 or 1. It's either an on or an off value. Well, if we were to ask you to write a program that requires thousands of lines of code and all zeros and ones, you wouldn't be able to do that. Okay. So machine code is zeros and ones. We can't read that. Well, what has happened over the years is they've tried to take the sequence of zeros and ones and turn those into human readable instructions. So for instance, we might have something like multiply 97, 9, 98. So we might have some kind of assembly language where this is a little bit more human readable. So the level of a language relies on the level of readability in human level language. So for instance, something like F equals 9/5 times C plus 32, this is a high level language where instead of just using F, we could make this Fahrenheit. Instead of C, this could be Celsius. So we could read along the way what it is. Uh, Something like put and performing this calculation and displaying the output, that's a high level language where eventually it gets turned into machine readable code. So keep in mind, under the covers, all the code that you write gets turned into a sequence of zeros and ones. And in Java, that happens with a compiler. So there is a compiler that's going to check, will your code compile or turn into something that can be executed at a machine level? Now, that's a little bit different than in Python. In Python, your code was interpreted. That was during runtime. So during runtime, it checks to see, can I turn this into a sequence of zeros and ones that is then executed? So it's a little bit slower in Python or in JavaScript than in something like C++ or in Java. 1.7, they do go through a little bit of language history, so keep in mind they kind of give you some popular programming languages. Long story short, down here, SQL, that's not a programming language. This is to get information from a database. But if you learn Python, if you learn Java, if you learn C++, C Sharp, if you learn some of these languages, then you are going to be employable. Section 1.8, something that you have to become good at is problem solving. So you have to be able to solve problems and then be able to turn that into a programming solution. So in this section, they kind of walk you through some details. So for instance, what if you wanted to get some socks out of your drawer and you're a person that just throws all of the socks together in a drawer? What would be a good process to find a matching pair? Well, an algorithm, a solution to this might be, all right, I'm going to grab a sock. And then I'm going to continue pulling out a sock until I find a match, and I'm not going to put the other sock back in. So once I find a match, I'm going to wear whatever socks I just found. So that would be a solution to this problem, and it'd be a pretty good solution. So again, as you're working as a new programmer, part of the things that you have to learn, not only the syntax of the language, but how are you going to construct a solution to solve it? Some of you might get frustrated by the solutioning of the problem. Reach out, make sure you get questions answered. Section 1.10, they provide some details on style guidelines. So we want, again, to have white space. We want each statement on its own line. Most items are separated by one space. So again, we want to have each new line on a separate line. Code blocks should always be enclosed with curly braces. And again, we like to keep the curly brace on the same line as where it opened. Same thing with a while loop. Loops are always going to be using curly braces as well. Else statements are always on its own line. In fact, I want the else statement to be up here, not on its own separate line. Always use curly braces even if there's only one statement. Naming conventions, we're always going to camel case, so lowercase letters until the first new words of the variable name. Variable name should always be descriptive, number of boxes, user key, instead of just like what's B or K. Constants are always uppercased and a underscore in between the words. Constants in Java are declared with the final keyword. And lines of code should be less than 100 characters wide. If some line of code is going to go over 100 lines, then we should press the enter key, separate it in a proper place, and then have it on the next line. We'll kind of close out here. So they do have some salary calculations. So we can kind of see, hey, I can declare my variables, get my inputs, perform my calculations, and then display my outputs. So again, they're displaying all of the output using two separate lines. And we saw earlier we could concatenate this. In fact, let's just kind of clean this up so we could perform this here. So inside the main method, I'm going to paste that code. And again, I would much prefer that we concatenate this output so it would look like this. And again, they're performing a calculation here. So really, I'd want this in parentheses. So that way, if I do any kind of other calculation, and if I were to have some addition operator, then it would perform the work properly. Crush fingers, if I run this properly, so it would have done the hours per week 20 and 40. Oh, we use just print. We want to use println. We're always going to print new lines every single time. So now if I run this, great, it's performing all of our work properly. Last one, they have a debugging section here. So they kind of talk about how do you go about debugging an issue by thinking. So I'm going to come in here and I'm going to do it by using what's called the debugger. So let's go ahead and copy this code right here. And let's go back to the Eclipse and let's paste in the code. So this code, we want to calculate the area of a circle and we are given the circumference, okay? So to calculate the area of a circle, the area is 2 times pi times the radius. Oops, sorry. Well, we're doing the area. Area is pi times the radius squared, which is the same thing as multiplying the radius by 2. So we know area is supposed to be pi r squared. Let's see what happens when we get down here. So I'm going to put a breakpoint in the code. So just come over here and click on this line to the left of line 14 here, or whatever line this is. And instead of hitting the run button, we're going to hit the debug button. And remember this, we're going to switch to the debug perspective. And this is going to open up a variables pane. So we can see we have variables and we have some ability to step over our lines of code. So I'm going to step over our line of code. Look, pi val, that's over here as a variable. And it said print out the circumference. So step over, and it's waiting for us to type in a circumference. So let's type in 10, press enter. So circle circumference, we see that that is 10. And then it's going to calculate the radius right here. And so look, I can hover over inside the code here. I've got the circle radius as 15.7. I can see that over here in this window as well. And then I can step over and I can see that it calculated the circle area. It took pi, which was about 3.14 times that 15.7-ish. And I can see that the circle area is going to be about 775. So I can again step over, or I can click the green run button. This will go until it finds another breakpoint. I don't have any, so it's just going to go ahead and continue and finish out. So we have the circle area is 775. Well, let's just kind of run the calculations ourselves. If the area of the circle is supposed to be pi times the radius squared, if I type in a circumference of 10, well, the radius is supposed to be circumference divided by 2 times pi. So I'm going to put a comment in here. Circumference equals 2 times pi times the radius. So that means to get the radius, that is circumference divided by 2 times pi. So if we were doing this mathematically, we would have c divided by 2 pi. The issue here is they don't have 2 pi in the denominator. What this would do is this would take circle circumference divided by 2, then it's going to multiply by pi. So right here, this is the problem. So now if I perform this arithmetic, oops, I want to click the debug button. Debug. So again, I can step over. It's waiting for me to type in a number, so I'll type in 10. So now it's going to take that 10 and it's going to divide by 2 pi. And so now my radius is about 1.59. This is going to give me the correct area this time. So sometimes we perform errors ourselves. Using this debugger, we can kind of come in here, go step by step, one line of code at a time, and kind of see what our variables and what calculations are happening. Okay, that's going to wrap it up for this recording. I will talk to you next time.